Hello everyone, this is Professor Kuehn. We've been talking about Chapter 4 in A Student's Guide to the Great Physics Texts, Volume 3. This chapter is titled Mueschenbroek's Bottle, and in this chapter, Benjamin Franklin is talking about his experiments with capacitors. Of course, the Mueschenbroek bottle or the Leyden jar is an elementary kind of capacitor. What Franklin did at the end of our last lecture discussion, what he had done is he had created what we would call a parallel plate capacitor. I want to say a few more things about that before I move on to the next letter that's included in this chapter. So what Franklin had done is taken a glass window plate and placed two lead plates, kind of sandwiched the glass between them. And then he had this idea to put multiple capacitors or parallel plate capacitors together. So what he did is he hung a lead plate with a glass pane between it and another lead plate. He had some hooks and he hung these from the ceiling. And then he took a chain and he attached that to another lead plate that had a window pane attached to it and another lead plate. And he did this with, I don't recall how many. And then he charged this up with a battery. So a positive charge here and negative charge here. He had a number of these. I'll draw one more. Lead plate, window pane, and lead plate, like this. And then he hooked these two ends up to a battery. This, by the way, is what we would call series capacitors. He is putting capacitors in series in hopes to obtain a larger storage of charge. It actually doesn't store more charge this way. But there's another way that he could have set it up. I'm not sure if he ends up doing this experiment or not, but you can place capacitors in parallel. So that would look something like this instead. He doesn't describe this in this particular chapter, but he may have done experiments like this at some point. I just have not come across it. But if you put the window pane and the lead plates organized in this way, and then string these together like this, and string these together like this, and then you hook this wire up to the positive terminal, you charge it up like that. This is what we would call parallel capacitors, or capacitors in parallel. And this actually provides a much better storage of charge than series capacitors. We'll come back to this later when we discuss electric circuits, but you can see here Benjamin Franklin thinking about different ways of arranging these charge storage devices, or these capacitors, in such a way as to store a large amount of electrical charge, or as he would say, a large amount of electrical fire. Okay, so let me leave that behind us right now, and let's go on to Franklin's next letter. So this is still in Chapter 4. Chapter 4 includes several letters by Benjamin Franklin. The next letter we're going to be talking about is Franklin's 1762 letter to Mr. Kinnersley. And in this letter, he talks about different theories of electricity. So let me give you a little, I mentioned some of this in the beginning of this discussion of Benjamin Franklin a couple lectures ago, but let me remind you and add a few comments. So there was a man named Jean-Antoine Nollet, or Abbe Nollet. He was ordained as a deacon in 1734. He studied theology in Paris, and he was a tutor to a private family in Paris, and he also ran a small laboratory. He was a very well-known and respected scientist. He was elected to the Royal Society in London in 1734 when visiting London, and he was a research assistant to Charles Dufay. I mentioned Charles Dufay before. So he was a research assistant to Dufay for 2 years before being elected to the Academy of Sciences in France. You might recall that Dufay was a proponent of the theory of electricity called the two-fluid theory of electricity. So Dufay thought that electricity was comprised of two separate fluids, a vitreous fluid that was created by rubbing glass, and a resinous fluid that was obtained by rubbing amber. And so Nollet, who was his student, also believed in two different kinds of electricity. So he called these something different. He called them effluent electricity, which is a kind of a matter that flows out of every part of an electrified body. And then the other kind of electricity was affluent, so effluent and affluent electricity. And affluent matter comes into a body from nearby atmospheres. So when you have an electrified object, there's a simultaneous flow of effluent matter away from that body and affluent matter into that body. So it's kind of like two fluids sliding past each other. That was the idea of Nollet. And Nollet, in fact, criticized Franklin's theory of positive and negative electricity, and that he also claimed he was kind of hostile to Franklin. And he claimed that many of Franklin's experiments had already been done in Europe, and Franklin just wasn't aware of them because he was so far removed from Europe. So that's a little bit of background on some of the other scientists who are active in the field of electricity at this time. Okay, so let's recall for the moment what Franklin's theory of electricity is, and then we're going to talk about some of the experiments that he does in order to criticize Nollet's theory and come up with his own explanation of what's going on. So remember Franklin's theory of electricity, which was based on his experimental work, at least in part. Franklin's theory of electricity, I'll highlight some of the main points. He said that all bodies are filled with some equilibrium level of electrical fire. That's what he called it. I guess it doesn't matter that much what you call it, but he called it electrical fire. All bodies are filled with electrical fire. He claimed that by rubbing them, rubbing or friction, disturbs this equilibrium. Disturbs the equilibrium and causes some objects to accumulate electrical fire. Objects to sort of accumulate this electrical fire. And in doing this, what happens is if you have objects that have excess electrical fire or electrical fluid, we call those, he termed those positive or positively electrified. And objects that have a deficit of electrical fire, he referred to those as negative or negatively electrified. Oops, take my time here. Electrified. Okay, and the prevailing idea that he inherited from people like Nollet was that nature acts in such a way as to reestablish equilibrium. So nature acts so as to re-establish equilibrium. Okay, if possible. Okay, so this equilibrium can be reestablished by the flow of this electrical fire from the positive to the negatively electrified object through some kind of conducting medium, like a wire, for example, or it can also jump across small air-filled gaps. Okay, so this is Nollet's theory, is that there's this desire for nature to reestablish equilibrium, and that is what causes sparks and flow of electricity. And to some extent, Franklin agrees with this theory. But the problem is that this implies, although this implies the flow of electricity from positive to negative, it doesn't really explain adequately the repulsion of positively electrified objects from other positively electrified objects. Nor does it explain the repulsion of negatively electrified objects from other negatively electrified objects. After all, the main principle is just reestablishing equilibrium. It really should only imply an attraction between positive and negatively charged objects. So this is one of the main points that Franklin is going to address in letter number 38. And this is what I show on the left side of the screen, letter 38 to Mr. Kinnersley in answer to the foregoing, and apparently they'd had some correspondences. Okay, and in particular, remember that one of the main problems here is he finds the repulsion of charges difficult to explain. So on page 52, what Benjamin Franklin does is he describes some of the experiments that seem to imply that there is electrical repulsion. And then he's going to come up with an explanation for this. So let me pause there, and we will pick this up when we get back together next time.